Hello and welcome to the first ever video on the C1 Edexcel course for A-Level. I just thought that while I go through this course I might as well make some tutoring videos and to help me and then to help others. I mean, I'm probably not the smartest out of the bunch, but I'm gonna try at least to help whoever needs help with this, so yeah. The first chapter we're going to start on is chapter 1, of course, and that's algebra and functions. So this chapter covers stuff like where you get x squared times, oh, there you go, x to the power of 3, it will equal x5, as there's a rule where when you times two how could you say algebraic terms together and they both have powers, the powers add up. However, you have to be careful then you put them in brackets so x squared in brackets to the power of 5 will not equal x7. Instead it will equal x10, and this is because when you have a algebraic term with a power to it inside a bracket to a power, the power is now times by each other, so 2 times 5 equals 10, whereas up here was 2 plus 3 equals 5. So that is a main basis for some algebraic terms. Okay, we can now start to move on to conversion of terms. So oh wait, no, crap, I forgot one. So say you got x to the power of 3 divided by x to the power of 2, you would get x with an invisible 1 up here, because you do 3 minus 2 equals 1, and yeah, that's all your basis. I just want to scribble that out, I don't like it. So yeah, x, when you times 2 plus 3 and you get the 5 in the brackets, 2 times 5 get you 10, and divide is 3 minus 2 equals 1. So yeah, that's great. Let's get a fresh new page. No, don't save that. So now we're going to do conversion to get things where it will end up as x minus 1, and x to the power of minus 1 is not minus x, it is 1 over x. I could not really explain that to you in broad terms, but I just know this is the general rule. You're gonna have to trust me on that. And then x minus 2 is not 1 over 2x, it's 1 over x squared, and it keeps going on like that. So x to minus 3 would be 1 over x to the power of 3. It'll keep going blah 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 all the way along like that, and that's how the minuses work. And now on to how you would get if you have to the power of a fraction. So if you have a power of fraction, what you do, well, okay, this is a bad example, scratch that. If you've got, what am I doing, if you've got 4 to the power of a half, this will equal 2, and this is because when you have this, I like to split into 2 sides. So you've got the top half, which is like where you do your squaring functions. So say you've got a 2 up there, you would do 4 squared, and that would give you the top half answer, and then you take whatever you did up there and you do it to a root. So you know what square root is, this is a square root. So here, if we look at it, we've got 4 to the power of 1 is 4, and then we take that and we square root it, and square root 4 of course is 2. So there you go, square root normally just doesn't have that. That's normally when you have like cube root like that, you would put the 3 there, 4th root or 5th root or blah 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 blah. But that seemed a bit messy, so let's try that again. Let's do something interesting. let's let's just do 9 to the half equal 3. So that's also another one. 2 to the power of 3 over 2. This will equal 2 to the power of 3, so that's 8, then square rooted, so it's going to be square root 8, which can then be simplified down to 2 root 2, but we're not learning size here. This is because you cube root the 2, then square root whatever answer you got up there. I should have a calculator near me to just make sure, because you know, I'm not 100% sure, but you never know, let's see. You might have already done this before me, but hey, let's see. 3 over 2, because yeah, that looks about like square root 8, doesn't it? 2.28 blah blah blah. Yeah. Okay, so that's how minus ones work and fraction ones work. Hopefully I am helping you learn. I'm not just confusing you. Now let's actually apply this knowledge to some questions from the book. So I'm going to be going, let's see, let's go from page 5. I'm going to be going from 1C, and I'm going to be doing question 18. So that is, I'll write out here, it says 3x squared minus x bracket 3 minus 4x bracket plus 7. Oh, plus 7 there, sorry if that's a bit dodgy. And what will that equal when we simplify it down? So we want to simplify it because we're not going to find the value of x because we don't know what's on this side. I shouldn't have done that. We want to simplify this. So we should follow the rules of BIDMaths, which is brackets. So you always do whatever's in brackets first, then you do indices, which are those, then you do division, then you do multiplication, then you do addition, then subtraction. So by following this rule, we do that first. So we've got 3 minus 4x. We can't do that because that's algebraic term, so blah. We indices, we can't do that, algebraic term here. We do not square the 3 because it's only the x squared here. We've got 3 lots of x squared is what it's saying here. D, division, we have no division. Multiplication, here is our first instance of multiplication. We have, let's take it like this, minus x times this bracket, and if we were to do that, we should get minus 3x, which comes from these two multiplying, and then you should do minus x times minus 4x, which is positive 4x squared. Notice how I've kept the minus in here. This is because when timesing, if it's a minus beforehand, you will generally keep that in. If it's a plus beforehand, you also keep that, and it'll be a positive. When it's a times and a divide, it won't affect this. So if this was a times, you just keep the x as a positive unless there's a minus in front of it. So whenever there's a minus in front of it, you take it as minus x times that. Hopefully that wasn't too confusing. So that's the bracket done. Then let's apply what we already know onto that. So 3x squared there. Oh, so now we've got all this. As you can see, if we go through addition, we have that, and subtraction, blah blah blah. Now we have some like terms here. We've got 3x squared and 4x squared. We can add these together. So these are both positive. No negative sign here, no negative sign here. So it will turn out to be 7x squared, if you get that. And then we have no more like terms, so the final answer should be 7x squared minus 3x plus 7. Should really check that, shouldn't I? Hold up 1 second. Exercise 1C, 18, 7x squared minus 3x plus 7. Yeah. So that's all good. Okay. Now let's. Oh, don't save. So that was to do with the timesing rules and the brackets rules and all that. Let's actually do question 20 real quick then. 3x squared bracket 2x plus 1 bracket minus 5x squared bracket 3x plus 4. Oh no, sorry, minus 4. Hopefully that didn't ruin anything you were writing down. So I'm just going to go through this one very quickly. I'm not going to explain why I'm doing it in order. So 3x squared times 2x, you would get 6x to the power of 3, because you do 3 times 2, x like that. 3x squared times 1, so plus 3x squared, minus 5x squared. So if we follow that rule, we can say, what's it? Blah, 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 blah. Let's get rid of that. Yeah, actually no, it'd still be minus. What am I doing? 5x squared, so minus 5x squared times 3x, you would get 15x3. Then you would get minus times a minus, so 4 times 5x squared, it gives you plus 20x squared. Gain like terms, we've got minus 15, so it would end up minus 9x to the x to the power 3 plus 23x squared. Let me just check that. I should really bookmark the answer page, shouldn't I? Yeah, let's just do that real quick then. Okay, there we go. Yep, minus 9x to the power 3 plus 23x squared. Just realised, wouldn't it be embarrassing if I got one of these wrong? Oh my lordy. Okay, let's now go do an indices and minus power question. You do receive. So let's do I'm doing exercise 1F question C, because this brings something interesting to the table. Okay, so x to the power of 3 over 2 times x to the power of 5 over 2. So if we remember, the multiplication rule when working with powers is 3 over 2 plus 5 over 2, and that is all you need to do, ladies and gentlemen. And because they're both fractions and they both have the same base, you can just easily put it as 8 over 2, which we all know simplifies down to 4, so it's equal to x to the power of 4. Should really put the x's here. There you go, to make things look a little bit better. Okay, so that was nice and simple, and that was combining two of the knowledges. Let's do 1i then. Oh yeah, that was 1c before, so 1i is 3x4 times 2x minus 5. So here it'll start to get a bit interesting. As you know, you add them together, the powers, and we have a new thing which I have forgotten to talk about, is we have coefficients, which are basically, that's a fancy word for numbers in front of in this question. So let's start by doing the powers first, because that's something we know. So 4 plus minus 5, and we know that if we have a plus and a minus, it goes to a minus, so 4 minus 5 is minus 1, so that should be our power. Now, because we have what's it called, coefficients, it's not just going to be x by itself, we have to do 3 times 2. and that applies. So if this coefficient was 5 and 3, you would do 5 times 3. That is just a rule, and that is how it works. So you do 3 times 2, and that would give you 6. So our final answer should be 6x minus, well, to the power of minus 1. And for you clever clogs out there, if you've already done this, that should go to 6 over x. Because remember, x to the power of minus 1 is 1 over x, and 6 times 1 over x would give you that, wouldn't it? Let me just check that. You always have to check your answers, because no matter how sure you think you are, you can make some of the silliest mistakes. Where was it? Yep, 6x to the minus 1. Okay, very good. Let us now move on to some of the back ones. Oh, we actually have something new to learn. I didn't know this was in this chapter. Okay, come on. So, what we're actually going to be learning now, remember how I said we weren't learning surds in this video? Well, now we are. So, say we have square root 20. It's one of my favorite square roots because of how simple it is to break down. You could say that square root 20 is equal to square root 4 times 5. Because it's underneath the square root, it's all fine. We can also say that square root 4 times square root 5 is the same as that. That's something that I used to get confused about, but that is a rule, and I'm 100% sure on that because that's what helped me get a right answer in a test. So now that we have two numbers, we can start to notice something. We know that square root 4 is equal to 2. So now we have a real, well, as we say, a real number. It's no longer a square number. So what we can simplify this down to, or that down to, is ultimately 2 root 5, because we've just taken the root 4 from this and turned it into 2. Yeah, and that's how surds work. So let's do one from the book here. Let's go with square root 50. So what this can be, so we have to like try and find a square number that would go into 50. 10, actually, oh no, what? Well, 10 ain't a square number. 25 is a square number, so you can go 25 times 2 and equal to, let's just keep this, 25 times root 2, and this can be simplified down to 5 root 2, because square 25, you get 5. A rule when you're working with surds, you always want to find the lowest square number. So if 16 can go into this, which is 4 squared, I would have used that instead of 25. If 9 could go in, if 4 can't go in. So yeah, this so that is what you always gotta make sure on. So let's check that answer. Where are we? Question 3 on exercise 1G. Forgot to mention that, by the way. 5 root 2. Yeah, so that's all good. We're gonna do, let's take this to the complex level now. Don't save, and do the hardest one on exercise 1G. That is root 12 plus 3 root, don't right click, root 3 root 48 plus root 75. So this is quite a lot to look at, isn't it? However, it is very simple. All you have to do is do it bit by bit. So let's start with this one. What square number could go into this? You have 4 and 3. 4 goes to 2, and then you're left with root 3. So 2 root 3 is that one. Now let's go to here. We'll keep the 3 out of this for now, and you'll see what happens there. It's a coefficient. Remember that fancy word for the number in front of a term. We're going to keep this out here for now. It's right there, and we're just going to work with this. The smallest square number that can go into 48 is probably 16, if I'm correct. 4 can go into that. Oh wait, have I got it the wrong way round? Oh no. Let's just do some quick maths, ladies and gentlemen. It's either 4 root 3 or 2 root 12. However, this one can be broken down, so it is ultimately that one. So it is. I was correct. Oh no, I wasn't correct. You always want the highest square number that can go into a third. Sorry, ladies and gentlemen, I am a ding dong. Let's actually use an eraser instead of scribbling out. So yeah, you always want the highest square number where that goes into a third. I feel very bad now. However, let's carry on. Now let's bring the 3 back in, because we can't just forget about it. It's just there. And now we bring the 3 back in. Because this has become a coefficient to the term, all we have to do is 3 times 4. Times 4. And that should ultimately give you 12 root 3. So that's pretty good. Then let's simplify this one. 75 is quite a big number. However, we just went over the square number that can go in this, and that is 25, and that would be times by 3, where we would end up with 5 root 3. Let's just do that. Okay. Now look at the equation we have formed. 2 plus 12 root 3 plus 5 root 3. It's quite a good equation, because guess what? They're all like terms. They're all root 3, so we can add them up. And if we do the adding of the coefficients, what do you get? That is right. Actually, I cannot hold my word on it, but that is right. It's not a 4, by the way. I do my 9s very weirdly. That is a 9. That's a 9, so it should be 19 root 3. And yes, it is. Just check the book. So that is thirds. Now let's move on. I believe this is the last stuff to go over. Let's move on to rationalizing the denominator. And this is when you have something like 1 over root 2. Fractions cannot be left in the form 1 over root 2, because there'll be a reason further on in maths, I'm sure. However, this is something that they recommend you do, so we might as well learn it. So what we have to do is we have to get this off the bottom and make it a real number, which is just like 1, 2, 3, 4, 5, 6. Okay, so the way we're going to do it is we're going to times this fraction by root 2 over root 2. And you're thinking, wait, you've just changed what this will be now. You're going to change the value of this number. No, we're not, because pay attention, this is actually 1. Whoa! Because we've got root 2 over root 2. Any number over itself is 1. So we're technically just timesing it by 1. However, let's just do it like this. So root 2 times root 2. You're going to get 2, because it's root 2. I mean, well, like, take it like this. If you have 2 if you have two 2's, you square root both of them, and then you times them by each other, you're gonna get 2. I don't know what I was trying to prove there. That was terrible. Okay, so now you've got to do the top line, and what you have here is 1 times root 2 gives you root 2, and that is a rationalized denominator. Okay, now we need to get a little bit more advanced. Say we then have 2 plus root. Let's just keep it root 2 for all these examples. 2 plus root 2. Now we can no longer times it by just root 2, because you would end up with 2 root 2, because you would have to do 2 times root 2 as well as root 2 times root 2. So to get rid of that denominator, we're going to have to times it by 2 minus root 2 over 2 minus root 2. And the reason why it's minus is because, let's go down here, when you have 2 brackets, because this is basically what we're doing, minus root 2, when you've got terms like that, so you've got a minus root 2 and that, remember when you've got double brackets you've got to times them by like this. So positive root 2 times 2 is 2 root 2. Root 2 times minus root 2, you would end up with minus 2, because root 2 times root 2 is 2, but it's a minus, so minus 2. 2 times 2 is 4, and 2 times minus root 2 is minus 2 root 2. Notice something here? These, oh no, whoa, ignore that. Oh, just ignore all of that. That's terrible. Okay, wait. So anyway, the minus 2 root 2 cancels out with the 2 root 2. So you would be left with minus 4 minus 2, which is 2. So funny enough. And then if we do the top part, it's just 1 times that, so you would end up with 2 minus root 2 over 2. And that should be the answer. I see nothing wrong there. 2 root, I'm just doubting myself because that seems very weird that the denominators are the same here. No, that's, yeah, minus 2. That's 4. That's, yeah, no, that's right. So yeah, if you don't believe me, well, I'm sorry, I don't know what to say. I'm 100% certain that's the answer. There you go, 100% certainty from Robbie. So now there was one more thing I need to go over, which is 1 over 2 minus root 2. If we just do this really quickly, because I'm spending a lot of time on this simple subject. 1 over 2 minus root 2, you would times that by, you guessed it, 1 over 2 plus root 2, because you need to cancel them out, and then we're gonna get 2 plus root 2 over 2. Oh wait, no, not over 2. You would get over 2. Shush, I did it right first off, over 2. Okay, so let's actually do some questions that they're giving us, instead of me just making them up. Okay, so let's go with 11 over 3 plus root 11. This is exercise 1H, question 17. So what we do here, if we follow the rule, we times it by 3 minus root 11. 3 minus root 11. This is technically 1. This, doing that, you would get 3 times 3, 9, cancels out, minus 11. 9 minus 11 is minus 2. So you would end up with, let's just do this. Let's just keep it so we remember, minus 2 on the bottom. 11 times that. Imagine it as if it was 11, 3 minus root 11. Imagine it like that. So you would get 33 minus 11, which is 22. And you would end up with 22. The minus then goes here because we only have one minus. So it's minus 22 over 2. We know that 2 actually goes into that 11 times. So our final answer should be minus 11. Whoa. Let me check that. Exercise 1H, question 17. Well, we did technically rationalize, well, because I've gone a step further, I've made it as simple as possible. This is a rationalized denominator over minus 2. And we did get to that point, remember? However, I then times out of these brackets and simplified out. So we were on the right track. So let's go file, new, don't save that. Let's go to exercise 1H, question 21, the hardest one according to them. It's root 2 minus root 3 over root 3 minus root 2. Now this is getting confusing, ain't it? So we got to times it by root 3 plus root 2, root 3 plus root 2. We cannot put them underneath the same root because it doesn't work like the multiplication like I did earlier. So we're going to have to do the double brackets. So let's do it. So 2 times minus root 2 times minus root 2 is, let's do a mental note here, 2. Root 3 times root 3 is 9. And then root 2 minus root 2 times root 3 is minus root 6. And root 2 times root 3 is positive root 6, and they would cancel out. So you'll end up with 9 minus 2, which is 7. So there's our denominator. Now up at the top we just got to do this. So minus root 3 times root 3, minus 9. 2 times root 2 is 2. And then minus root 3 times 2 is minus 6, and you'll notice it'll cancel out and it will give you a minus 7 in the end. So we put that on top. That might be the answer they want in the book. If you want to simplify it further, it will become minus 1. Let us check. Nope, they just simplified it. Okay, they just do willy-nilly with this. So yep, the answer is minus 1. But yeah, actually I kind of like that one. That was very nice. So let's go on to the mixed exercises and finish off this video. So mixed exercises 1L, I believe. HI. Oh, it's I. Okay, so let's do this one. It's 1D, 4b squared. Ooh, come on, there we go. 4b squared times 3b to the power 3 times b4. We multiplication, so you add up the powers. 2 plus 3 plus 4, that's 9. So it would equal b to the power of 9 then you do the coefficient times 1 times 3 times 4. 4 times 3 is 12, so you would end up with 12b to the power of 9. I shall check. 1d, 12b to the power of 9. So that covers what I covered in this video quite early on. Don't save. Let's go with question 2d. Actually, going down that trend is going to take a long time, so let's skip past that. I believe we're brave enough to do that. Let's do this one. Let's do question 5d. 3x to the power of minus, no, not minus a half, just a half. Oh no, oopsie daisy, I cannot read. Let's erase it. A third divided by 6x to the power of 2 over 3. Dividing, you do the minus power, so 1/3 minus 2/3 is going to give you a power of minus a third, and then you do 3 divided by 6 gives you a half. If you want to get very cool with this, you can do 1 over 2x to the power of a third, I believe, because that simplifies down to 1 over x to the third, and then you do a half times that. You just do the denominators times, and yep, that should be it when you've got it in just one fraction form. Let's go to 6, because this is a new way of looking at what we're doing. We're going to do 6b, so we got 225, oh this is very shoddy writing, 225 over 289 power of, what is that, 3 over 2? Yeah, 3 over 2. So what we should do here is we should just take these terms by themselves and apply this to them separately. So basically we're doing 225 to the power of 3 over 2 and 289 to the power of 3 over 2. So if we do that, I cannot do this in my brain because I am not mad. You have to do 225 to the power of 3, then square root whatever answer you got, and that should give you 3375. Now let's do this. 289 to the power of 3, then root that answer. You would get 4913, and that is a unsimplified down answer. However, if I was to put that in to the calculator, because I'm also not mad, so I can't work that. Oh, sugar. Nope, that's the smallest it's going to go, so that should be the final answer for 6b. 6b. Yep. Man. Oh, something to take into consideration. It can be plus or minus this, and that is because why is that? Because that's it, because you're square rooting, so you're square rooting whatever that is. We know that minus 2, let's take this logic, minus 2 squared equals 4, oh crap, equals 4, and 2 to the power of 2 equals 4. So say we had whatever 225 to the power of 3 was, and we square rooted that, we wouldn't know if it was a minus or a plus. because it hasn't defined. So we have to put plus or minus the answer, and that is why I always forget that. Something I need to work on. Okay, let's just do one more question then, because I am getting quite tired. But not of you guys. You guys are lovely. If there's many of you, I don't know how many there are of you. Maybe there's no one, or I'm all alone. But this is 8D. The last question in mixed exercise is 1I, and it's going to be rationalizing the denominator. So, because this is a plus here, we gotta do root 23 minus root 37 root 20. Don't do that. There we go. Minus root 37. Remember, just do the double brackets one, multiplication, double brackets multiplication. Root 23 times root 23, 23. Let's do mental notes down the page here. Minus root 37 times 37 is minus 37. Then the root 23 times the root 37 terms would cancel out, so we have 23 minus 37. That should give you minus 14, if I'm correct. Yep. Now let's do the top. We have minus root 37 times minus root 37. That's going to give you 37. Then you got root 23 times root 23. You're going to get 23. In this case, the terms of root 23 and root 37 do not cancel out because these are the same signs. So we have to factor them in. So minus root 37 times root 23. We're going to get minus 37 times 23, and we're going to get two lots of that. If we were to put this, we need to now find out if this can be simplified down further. 23, so 37 times 23 is 851. Because there's two lots of it, let's say minus 2 of that. The biggest square number that can go into that, I believe, is, I think it's 9. Maybe not. Divided by 9. No, okay, I'm wrong. Let's just go through the list. Okay, not divided by 16. 25. No. Wait, why did I even do 25? 36. No. 49. No. No, it wouldn't be that. 81. No. 121. No. 144. Come on, there must be one. 2. No. Whoa, what am I doing? 4, 9, 16, 144, 169. No. 196. No. 225. No. 200 and 256. No, I'm just gonna give up there. I'm gonna say no. So actually we're gonna be just left with that. Oh, that is quite a weird one. So we've got 37 plus 23 plus this. So we would get 60 plus minus 2 of 851. I feel I'm not too confident about this. I'll let you guys know. However, I do have to check the answer, so all truth will be revealed soon. I was close, but somehow huh? Oh, okay. Okay, they're clever. Basically, this is correct. This is correct. However, it can be simplified down more. And that is because this, and this can all be divided by 2. So our final most simplified answer should be 30 minus root 851 over 7. Well, minus 7, and the minus would go out here because we only have one minus on the outside. Here's a blah blah blah. So yeah, that was algebra. What chapter was it? Algebra and algebra and come on, algebra and functions. Jesus, that was too long. So yeah, that was Algebra and Functions, Chapter 1 in C1 Edexcel course. Thank you for watching, and I hope you found this helpful, and see you later.